Hello again. I just wanted to make a little video to help you with some of the past paper questions that I've set you this week. You're going to have to do some revision. That's part of the purpose of the next 2 weeks. We want you to get some consolidation of things that we've done before. So have a look back. I put the relevant pages on Show My Homework so you know which bits to do. So make sure you've gone back through those. We're looking at the different reactions of the four. We've done four functional groups so far this year in year 12. We've done alkanes and reactions of alkanes. Remember those, the radical substitution reactions? We've done alkenes. Remember double bond breaks and they add in. So we have electrophilic addition reactions for those. Remember, you're going to need to know the curly arrows for that bit. We've also done alcohols. So we've done quite a few reactions with alcohols, obviously oxidation, removal of hydrogen to start with, and then addition of oxygen. We've done, what else have we done with those ones? Dehydration or an elimination reaction, where we remove the OH from one carbon and an adjoining hydrogen and it makes a double bond. We've also done a substitution reaction for that one, where we remove the oxygen and we put in a halide, like a bromine or something like that. And then we've also done the haloalkanes. And for that one, we've done a nucleophilic substitution reaction where we've removed the bromine and we've put in an OH. So these are things that you need to be able to be really familiar with. I have said before, and this is really important, here we go, here's your textbook. Okay, this is the page you want here, look, 271. This diagram here, actually the previous page as well, look, this is a really useful, no, I can't do this, there you go, this bit here, okay, this bit is really, really useful, has a summary of all of the reactions that we've done so far this year, and then here's the little diagram that we're going to be using today in order to be able to answer some of these questions, okay? So it's a case of today's kind of questions, the past paper questions that I've given you for this week's homework, basically put all of those together. Some of the questions just deal with one functional group and one lot of reactions. Others of them try and put them all together. Those are the tricky ones, so those are the ones that I want to go through with you in this video. Okay, so I'm going to pop up on my screen. You can get this in front of you as well. Okay, so right. Can you see this now? I'm hoping you can see all of this here. Okay, so we're going to start with question 6. If I scroll all the way down to question 6, here we go, where are we? Question 6. I'm going to let you do all those other ones by yourselves. Mark scheme is at the end, as usual, so do use that where you need to. Okay, so these ones you are going to be, these kind of questions you're going to become increasingly familiar with. Okay, it's what my year 13s hate most and ask for most practice. So they love this stage where you get boxes like this and like this, and you have to work out what goes in those boxes. And they give you something and you have to try and figure it all out. Okay, so you'll see there's one in 6 there. Oh, there's another bit there. There's another one in 7. I think there's one not in 8. But I think there is one. Is that it? Is that it? Okay. Did I miss one? I thought there was another one. Maybe it was in 3. Here we go. We're actually going to start with number 3. My mistake. Start with number 3, and then we're going to do 6 and 7 so that we go through each of these. Okay. So let me show you how we go about these. Okay. So these ones here where you get little boxes like this, they're very, very common questions. We call them multi-step organic synthesis questions, because it's not just about doing one reaction. Okay, obviously you've got an alkene, we know alkenes do electrophilic addition, so therefore we're going to break the double bond and we're going to add something, but that's not what it's asking, because what we've got to get to is this one. How are we going to do that? And it's a 2-step process. We're going to react this one with something and get something else here, which you're going to have to identify, and then we're going to get from here down to this one that we want. Okay, so I'm going to show you how to do that. So here's the question. It says the flowchart shows how 2-methyl-butetuene. So this is 2-methyl-butetuene. So 1, 2, 3, 4. Okay, so that's bute. You've got a methyl on number 2, and your double bond is on number 2. So it's 2-methyl-bute-2-ene, can be converted into a number of organic products. Complete the flowchart by drawing an organic structure in the box below. Okay, so we need to react this with something. And so the first question asks us to identify, obviously we've got to identify what the intermediate is, but we also need to re-identify what we've reacted it with in order to get that. Once we then get that, we then will react that with potassium hydroxide to get this. Okay, right, I'm going to go back to here. You keep it up in front of you, okay, so you can see what you're doing, all right? But I want to show you this now, okay? So here's your book and here's your diagram. Let me grab my diagram. Okay, so can you see that? Hang on a minute. Let's get it a little bit higher so you can see. Right, whoops. There we are. Okay, so we have got, where's my alkene? There's my alkenes. There, okay? So we have got an alkene, and eventually we want to go to, you see, an alcohol. Now it's a 2-step process. Obviously I can go directly from my alkene to my alcohol, but you've got to find an intermediate. So can you see somewhere where I could do 2 arrows from my alkene to my alcohol, 2 arrows where I get something in between, so I can react it, form something, and then react that thing to get the alcohol. Okay, I'm just going to let you think about that for a second. Okay, all thought about it? So hopefully you worked out that we could go from an alkene across to a haloalkane and then go down to the alcohol. So what we're looking for in that first box is this, a haloalkane. Right, if I go a bit closer so you can see it, what do we react with a haloalkane? Well, we react a hydrogen halide. Okay, let's go back. Oh, I don't know. Actually, rather than go back, because you can keep it in front of you. Okay, I'm going to draw it over here. So we have got, here's my carbon double bond. I've got my methyl up there like that. I've got another methyl up here like this. I've got another methyl down here like that. Okay, and I've got a hydrogen here. Okay, now we know that we want over here in this box, which is what we're trying to draw at the minute, we want a haloalkane. Okay, and then we know once we've got my haloalkane, we can go down here and we can get my alcohol. Now, before we do this, okay, we need to have a look at my alcohol a little bit more closely. Okay, so these are tricky questions and they take a little bit of getting used to, which is why I'm doing it with you rather than you doing it by yourself. Okay, so here we go. Here's my alcohol. Now, you should be able to see, all right, that I've actually got 2 alcohol groups here. This is a diol, okay? So how would we name that? 1, 2, 3, 4. So it's butane. And I've got 2 ols. So it's butan, 2, 3 diol. Okay, so that's what we've got here. Now, I am going to need, if you remember in my book, in my diagram up here, my diagram, yeah, I'm going from an alkene to a haloalkane. So a haloalkane, what does that do? It breaks the double bond. So my double bond is going to be broken, and I'm going to add in 2 things there, okay? So if I add in 2 things there, I'm going to just twist that one round a bit. So that will now be an H. That one will be a CH3. That one will be a CH3. And that one will be a CH3. Everybody happy what I've done there? I've just redrawn this one with the double bond broken like that, and with 2 bonds there, and I've just kind of straightened it out. Yeah, that's all I've done for the minute. Okay, now if I put a bromine on there and then I react that one, what's it say with KOH? We then do a substitution reaction, the bromine comes off, the OH goes on, and I get an OH there. But I also need an OH here. So I'm actually going to need a bromine here as well, okay? So I'm actually going to need this as my product. How do I get to there? I react it with bromine, 20 degrees C. Now I'll show you how I get that in a minute, okay? Because hang on, let me just show you. If I have a look again at that diagram, you know, page 271 will become your new favorite page in your textbook. Okay, now, oh gosh, let me get this in the camera. Right, so we're starting here, an alkene. We're wanting to go, whoa, I'm doing it in the wrong direction because it's backwards. I'm wanting to go down to the alcohol. Now, in your book, it shows it as, here we are, a haloalkane. But actually, we're actually going to use this one, dihaloalkane. So that one also, it does the same job, okay? Each bromine will get substituted into the alcohol. So if we look at that very carefully, can I show you? Oh, I can't find where my camera is. Here we are. So it's bromine and 20 degrees C, okay? So those are my conditions. So here, go back to this, okay? So this is what you put in your box. Where is it? Here we go. Here we are. Okay, so this is what you put in your box, this bit here, okay? It's what you put in your box. And then question B says, identify reagent A. Well, that's your bromine here, and your 20 degrees is your conditions, okay? But your reagent is bromine, okay? So that's the answer to that one. Okay, and then I'm scrolling it down. It says, in the flowchart, reaction R forms a mixture of two alcohols that are structural isomers of C5H12O. Okay, so let's look back up. Here we go. So we've now got, again, an alkene, reaction R, mixture of two alcohols. So we go back to my book again. This is why you need to learn this diagram off by heart, okay? If you can do it this year, you'll save yourself a lot of grief next year. Right, let me get it in the right place. Okay, so we're starting here, and we're wanting to go down to the alcohol. Now I can't read back to front, so I'm gonna have to turn it round. Okay, so it says, here we go, concentrated sulfuric acid. No, that's the wrong direction. That's going alcohol to alkene. We're going alkene to alcohol, so steam. Phosphoric acid catalyst, 300 degrees C. Okay, so what we're doing is we're doing a electrophilic addition with steam, double bond breaks, one alcohol, the OH group goes into one of the carbons and the H group goes into the other. Now, obviously it can go two different ways. So question one says state the reagents. So that's steam, okay, and conditions. So that is acid catalyst, 300 degrees C, 60 to 7 atmospheres. So pressure, high pressure too. Then it says what terms meant by structural isomers. You can answer that one for yourself. And then it says draw the two structural isomers. So let me have a look at that one. So remember, come back to this here, okay? So we're adding in steam. So we can either add in water like that, where the OH goes into there and the H goes on there, or we could add it the other way around, like that, where the OH will go into that one and the H will go into that one, yeah? So remember, I get two different possibilities for this. So let's just draw out what the two different possibilities are. Okay, so again, I'm just twisting this round, exactly what I did over there. And I'm going to put my OHs on the bottom, like that. So see, gosh, I've run out of space on my mini whiteboard. Sorry about that. I'm going to make this really small. CH3, there you go. So here we are, and then we'll draw the other one over here, like this. CH3, like that. CH3, CH3, H. Okay. So I could either have my OH on this one and my H on that one, or I could have my H on that one and my OH on that one. Can everybody see that? Yeah, so those are my two possible structural isomers. That's for part 3. And then part 4 suggests why 2-methyl-butyrene is less soluble in water than either of the structural isomers formed. Think hydrogen bonding, and you can answer that one yourself. Okay? Right, so everybody happy with that one? Let's try another one, okay? So that's your first one to have a go at. Same principle with all of them. You use page 271 and you figure out what you've got to start with, where you're going and how you get there. Use your diagram. Okay, so let's scroll down. Oh, hang on a minute. I need to share this one. Hang on. Let me get onto the right one and then I'll share my screen. How do I share my screen? There we go. Sharing my screen again. Okay, so we're back onto this. All right, so we're now onto 6A. So it says compound B shown below can be used to synthesize organic compounds with different functional groups. So we've got this one. It's another alkene. So we're starting off with electrophilic addition once again. Okay, some reactions involving compound B are shown in the flowchart below. Complete the flowchart, show the structures of the organic compounds C and D. Okay, this one's actually a little bit easier, I think, personally. Right, so let's get page 271 up again. Right, I tell you what, you keep it up on your screen and I'm going to stop sharing so you can see me rather than the question, but keep it up on your screen so you can see it, okay? Right, so if we have a look at compound B, if I get this up here again, like this, is an alkene, which is, where are we? Here, okay? So we're on an alkene. And we wanted to get it from concentrated sulfuric acid and heat. So you look along the arrows. Can you see along the arrow here? It says concentrated sulfuric acid and heat. Where did that come from? It came from the alcohol. So compound C must be an alcohol. So let's have a quick look at what the alcohol must look like in order to get that. Remember, this is a dehydration or an elimination reaction here. So here's what we're trying to get over here. There's a CH3 up there. There's a CH3 down here. There's an H there. And there's another H there. Okay. Here's my box, which is what I'm trying to find out. And we know this is a dehydration. So dehydration removes an OH from one and an H from the other. Does it tell me which one? Does it matter which one we're doing? To find out. Ooh, actually, there's another clue. Okay, so let's just kind of pop this in here. Like, so I'm just going to break the double bond for the minute. Okay. I'm just rearranging it slightly. So, okay, here we go, like this. Now, I've got two possibilities. I could have the OH there and I could have the H there, like that. Or I could have the H there and the OH there. Now, we need to use some information in the question to be able to help us to decide which one it is. Can you see that when it says compound C, it says then potassium dichromate and sulfuric acid and reflux has no reaction. So this is an alcohol, which is the only type of alcohol that has no reaction, no oxidation when we do reflux. This is the pause where you all tell me the answer. Okay, I'm assuming you got it right. Tertiary alcohol. So if I've got the OH on this carbon, can you see that that carbon is attached to 1, 2, 3 other carbons? So this one is a tertiary alcohol. If I had done it the other way round, so if the OH was there and the H was there, this would be a primary alcohol and it would oxidize. So we know it can't be that one. So it has got to be this one. See what I mean about them being a little bit like puzzles? You have to kind of put all the information together. See, I love puzzles. So I love these kind of questions, but I know that some people are going to struggle with them. Right, final bit. It then says compound B does polymerization to get compound D repeat unit. Do you remember how to do that? What do? You put your double bond in the middle, yeah, like this. Everything else sticking up and down. Do you remember? Everything else sticking up and down. So you draw your monomer, everything up, sticking up and down, double bond in the middle. You break the double bond. You put your bonds going either side, square brackets around it, and a little N at the bottom. Okay. and that's your compound D, your repeat unit. Okay, let's have a look. I'm not going to do 6B part 2 because it's almost identical to question 3 that we did just a little bit ago. So you can work that one out yourself. You start off with an alkene. You're wanting to end up with a diol. So remember, you're going to have to make a haloalkane in the middle. Okay? All right, so let's go on to question 7. So I'm going to share my screen a minute so we can have a quick look at it before I go through it. Okay, so there we go. Right, so this is question 7. So this one says, we've got hex-1-ene, okay? It's reacted with hydrogen, HCl, and bromine, as shown in the flowchart below. Complete the flowchart to show the structures of the organic products of these reactions, okay? These ones, I think, are relatively straightforward. So I'm going to unshare my, do we need anything else from this one? No, I don't think we do. Okay, so unshare my screen so you can see me. Right, I'm going to just draw out hex-1-ene here, just to make it a little bit easier for us. So here we go, hex-1-ene. There's 1, 2, 3. Do you mind if I just make, I'm going to make it easy for myself, okay? Remember, we're only really worried about the double bond. We don't really care about the rest of it. So hex is 4 more carbons. So it'd be 1, 2, 3, 4 carbons. How many would that be? 9 hydrogens? 9 hydrogens? If it's not 9, you correct it, okay? I think it's 9. So that'd be 9, 10, 11, 12. Do I get 12 altogether? 3, 5, 7, 9, 10, 11, 12. Yes. Okay, so I did do it right. Okay, so we've been asked up here with hydrogen. We've been asked here with HCl. And we've been asked here with bromine, okay? Remember, on each occasion, the double bond is going to break. So you're going to end up with, I'm not going to draw the boxes this time. Okay, so let me draw these ones like that. Okay, so C4H9 goes there. And we'll have hydrogen, hydrogen, hydrogen. They're all going to do the same. They're all addition reactions. So I'm going to have C, C4H9. Okay, here we go. H, H, H. Those two, we'll see those in a minute. And then my last one down here, C4, H9, H, H, H. Right, let's do the easy ones first. This one's easy, okay? What we're doing is we're adding in the H2. So one goes in there, one goes in there. That one's nice and easy. This one's also very easy because it's Br2. So a Br goes in there and a Br goes in there. This one's slightly more tricky because it says major product. Do you remember Markovnikov? Does that ring any bells, Markovnikov's rule? The thing that isn't hydrogen adds to the least hydrogenated carbon. So we look at this one and we look at that carbon. How many hydrogens does that carbon have on it? It has 2 hydrogens. What about this carbon? This carbon only has 1 hydrogen. So this carbon is the least hydrogenated carbon. So the thing that isn't hydrogen will add to the least hydrogenated carbon. What's the thing that isn't hydrogen? It's the chlorine. So the chlorine will add to the least hydrogenated carbon, and the hydrogen will add to the other one. And that gives us our answer. Okay? Right, so I've done the trickiest bits. Please use this page and that diagram. It will give you all the information about how the reactions go. If you want to look up mechanisms, check back in your notes or look at the PowerPoint that I gave you. I put all the mechanisms onto that one. It's just a summary sheet of everything that we did so far. And do come to our online question and answer sessions if you've got any questions. We can always talk it through in an audio session if necessary, or of course I can make another video if you want me to. Okay, hopefully you'll have some fun doing these ones. They will take you a little bit longer than up to now, I think, but worth it to get the practice. Do remember, after half term, Miss Malhotra is intending to give you some kind of end of year test, however that will look. So we do need to be getting ready for that. Okay, so have fun, and hopefully I'll talk to you later on this week. Okay, bye.